How can a single sentence, spoken in the wrong moment, bring down an entire industrial giant? On the morning the disaster began, nothing looked unusual inside the shipyard. Cranes moved slowly against the grey sky, welding sparks cut through the air, engines hummed in their familiar rhythm. Hundreds of workers followed routines repeated thousands of times before, trusting procedures, checklists, and brief radio confirmations that had always worked in the past. This was one of the largest shipyards ever built, a place designed to handle complexity, scale, and pressure without failure. And yet, hidden inside that apparent normality, a small communication breakdown was already in motion. It did not start with an explosion or a mechanical failure. It started with a message, a short instruction passed between teams working in different sections of the yard. The words themselves were not wrong. The timing was the context was incomplete, and the assumption behind it that everyone involved shared the same understanding was fatally incorrect. One supervisor believed a critical operation had been paused, another believed it had only been adjusted, a third assumed confirmation had already been given. No alarms sounded, no red flags were raised. On paper, everything still looked under control. Shipyards are environments where thousands of independent actions must align perfectly. Structural loads, ballast adjustments, dry dock configurations, and support systems depend on precise coordination. When communication flows clearly, the system absorbs small mistakes. But when information becomes fragmented, the entire operation starts drifting toward danger without anyone realizing it. That morning, teams continued their tasks, unaware they were now operating under conflicting assumptions created by a single misunderstood exchange. The most dangerous part of communication failures is not silence, it is false certainty. Each team believed they were acting correctly. Each decision felt justified in isolation. The absence of immediate consequences reinforced the illusion that everything was fine. Minutes passed, then more minutes. During that time, weight distributions changed, mechanical stresses increased, and safety margins quietly eroded. The shipyard was no longer operating as a unified system, but as disconnected islands of decision-making. In highly complex industrial environments, warnings rarely arrive as dramatic signals. They appear as subtle inconsistencies, delayed responses, or messages that feel slightly unclear but not alarming enough to stop operations. This is exactly how catastrophic failures bypass human intuition. No one wants to be the person who halts a massive operation over what seems like a minor misunderstanding. Questioning instructions can be perceived as incompetence or insubordination, and so, people proceed, hoping clarity will come later. What makes this event especially chilling is how ordinary it felt in real time. There was no sense of crisis, no visible danger, just professionals doing their jobs, trusting that someone else had verified the bigger picture. But the system was already unstable. One team's action depended on another team's pause that never truly happened. Structural limits were being tested without acknowledgement, and the longer the misunderstanding persisted, the harder it became to reverse course. By the time the first physical signs of trouble appeared, the shipyard had crossed an invisible threshold. The margin for correction was gone. What followed would unfold rapidly, violently, and irreversibly, shocking an industry that believed its safeguards were sufficient. All of it traced back to that first moment, warning delivered, received, and interpreted in completely different ways by the people who needed clarity the most. If you're following this story closely, take a moment to think about how a single miscommunication could trigger catastrophic consequences. Leave a comment, sharing what you think went wrong in that initial exchange. Your insights matter. Understanding these failures is crucial, not just for historical context, but for preventing similar disasters in the future. If you want to keep learning about industrial tragedies and the hidden chain reactions that cause them, make sure to hit the like button and subscribe to the channel. These stories are more than just events, they're lessons, and your engagement helps us bring them to more people. The shipyard was enormous, a sprawling network of dry docks, cranes, warehouses, and assembly lines stretching for miles along the waterfront. On paper, every process was documented, every team assigned clear responsibilities, and every procedure rehearsed countless times. But scale can be a double-edged sword. The bigger the operation, the more complex the interdependencies, and the more difficult it becomes to ensure that every action aligns perfectly. That morning, the ships in progress were Enormous steel giants weighing thousands of tons, hulls partially welded, compartments still empty of critical structural support. Any misstep in sequence could shift the entire balance. Inside the control rooms, supervisors monitored the operations on screens and in logbooks. Sensors tracked mechanical pressures, fuel transfers, and crane loads. Alerts popped up when limits were approached, but they relied on human interpretation and manual responses. In the midst of this technological complexity, human error was not just possible, it was inevitable. And when human error intersected with miscommunication, the stage for disaster was set. The yard's environment was high pressure, deadlines were tight, and financial and national stakes were enormous. Shipbuilders moved quickly, sometimes bypassing secondary checks to keep pace with schedules. The culture emphasized execution over hesitation. Safety protocols existed, but enforcement depended on context. If someone noticed an anomaly, raising the alarm could be seen as a disruption, an unnecessary delay. That invisible social pressure created an unspoken agreement. Assume the instructions are correct, trust the team, and keep moving. On the ground, welders, crane operators, and engineers worked side by side, often unaware of the decisions being made just a few meters away. Coordination relied heavily on verbal communication and hand signals over the ambient noise of machinery. Small deviations slightly off, measurements, delayed transmissions, or misunderstood directives could ripple through the system, multiplying their impact. That morning, every team believed they were acting in the correct sequence, following what they assumed were verified instructions. Meanwhile, the structural realities of the ships themselves added a hidden layer of risk. The partially assembled hulls were far from stable, and minor shifts in weight distribution could create enormous internal stress. Cranes suspended tons of steel, balanced precariously, their movement dependent on precise coordination with other lifts and counterweights. Pipes and cables had to be aligned with millimeter precision to prevent deformation. In this environment, even a small miscommunication could cause a sequence of mechanical stresses that no human could correct in real time. By late morning, unnoticed misalignments had begun. Cranes moved fractions of an inch differently than intended. Welders applied heat to sections slightly out of sync. Support braces were not fully in place when large sections were moved. Each of these small deviations was minor on its own, but together they set the stage for a catastrophic chain reaction. In such a highly interdependent system, the margin for error was virtually non-existent, and the consequences of even a single communication failure were magnified exponentially. As the day progressed, nothing seemed out of place to the teams. Operations appeared smooth, supervisors nodded at checklists, and managers assumed compliance. But beneath the surface, the invisible tension between human error, technical precision, and environmental complexity was building, air pressure so subtle that no one could detect it until it was far too late. The industrial environment itself, perfectly organized yet unpredictably fragile, was ready to betray them. Long before metal twisted and structures collapsed, the most critical failure had already occurred inside people's minds. In complex industrial systems, technology rarely fails first. Humans do. And in this shipyard, the danger was not ignorance or incompetence, but interpretation. Each team received fragments of information and instinctively filled in the gaps with assumptions shaped by experience, routine, and pressure. One supervisor heard that a critical operation was on hold and understood it as a complete stop. Another interpreted the same phrase as a temporary delay that would resume shortly. A third never received the message directly and assumed normal operations continued. No one felt confused enough to ask for clarification. The language sounded familiar. The tone was calm, and nothing appeared urgent. That familiarity was deceptive. It created confidence without verification. In industrial environments, experience can become a liability. Veterans rely on patterns. When something sounds similar to past instructions, the brain categorizes it automatically. This cognitive shortcut saves time, but it also blinds people to subtle differences that matter. That day, phrases that had always meant one thing were used in a slightly different context. No one noticed, no one questioned it. The system moved forward based on interpretation, not confirmation. Another human factor made the situation worse: hierarchy. Junior staff hesitated to challenge instructions that seemed to come from above. Mid-level supervisors assumed higher management had the full picture. Senior managers believed their directives were being executed exactly as intended. Each layer trusted the other, creating a closed loop of false certainty. When everyone assumes someone else has verified the details, verification never happens. Stress also played a silent role. The shipyard was operating under intense deadlines. Delays meant financial penalties, political pressure, and reputational damage. In such environments, stopping operations feels dangerous, even when something feels off. Workers learn, often unconsciously, that momentum is valued more than caution. Pausing to ask questions can feel riskier than proceeding with incomplete information. The most chilling aspect is how normal everything felt. There were no raised voices, no arguments, no visible conflict. The communication failure did not feel like a failure at all. It felt like routine. And that is precisely why it was so dangerous. When systems fail loudly, people react. When they fail quietly, people continue until the consequences become unavoidable. As decisions stacked on top of misunderstood decisions, the gap between reality and perception widened. Teams believed safety margins were intact when they were already compromised. They believed sequences were synchronized when they were drifting apart. The disaster was no longer a possibility, it was becoming inevitable. And still, no single person could see the whole picture clearly enough to stop it. At this stage, the failure was no longer technical, mechanical, or structural. It was human, systemic, and deeply embedded in the way information moved through the shipyard. What came next would expose just how dangerous that invisible breakdown had become. As the operation continued, the most dangerous condition inside the shipyard was no longer confusion, but conviction. Each team was confident they were executing the correct plan. Every action felt justified, logical, and aligned with what they believed the overall operation required. This is where communication failures become truly lethal, not when people are unsure, but when everyone is certain in different directions at the same time. One department adjusted its workflow based on the assumption that a critical load would remain static. Another proceeded as if that same load was about to be moved. Engineers trusted that support structures had already been reinforced. Crane operators believed those reinforcements were still pending. Each belief was internally consistent, supported by partial information and past experience. No single action appeared reckless on its own. The danger lived in the gaps between them. In large industrial environments, coordination often relies on implicit understanding rather than explicit confirmation. Teams develop shared habits over time, shortcuts that usually work because conditions are familiar. But on that day, conditions had subtly changed. A deviation in schedule, a delayed confirmation, a message passed verbally instead of through formal channels. Each small shift weakened the shared mental model that kept the system aligned. Conflicting commands did not arrive as direct contradictions. They arrived as parallel instructions that never intersected. One supervisor told their crew to proceed carefully, assuming others were standing by. Another emphasized speed, assuming safety checks had already been completed. Neither instruction was technically wrong. Both were dangerously incomplete. And because they came from different branches of authority, no one felt empowered to reconcile them. This fragmentation was reinforced by the structure of the organization itself. Departments operated in semi-isolation, connected by reports and brief exchanges rather than continuous shared awareness. Information moved vertically faster than it moved horizontally. Critical updates traveled up chains of command, but did not always flow across teams in real time. By the time discrepancies reached higher management, they were filtered, simplified, and stripped of urgency. Meanwhile, physical operations inside the shipyard were becoming increasingly misaligned. Loads were being redistributed based on outdated assumptions. Mechanical systems were stressed beyond intended limits without triggering alarms, because the parameters being monitored no longer reflected the real situation. Each team's confidence acted as a blindfold, preventing them from noticing warning signs that existed just outside their narrow field of responsibility. The most tragic element is that at multiple points, someone sensed something was off. A hesitation before issuing a command, a pause while reviewing a checklist, a brief moment of doubt that was quickly dismissed. In environments driven by momentum, doubt is often interpreted as weakness. So it was ignored. Operations continued. The system moved forward, locked into a course that no single individual had chosen deliberately. By the time these parallel realities collided, The shipyard was already operating beyond its safe limits. The belief that everything is under control had become the final barrier preventing intervention. What followed was not a sudden mistake, but the inevitable consequence of many people being right individually, while the system as a whole was catastrophically wrong. There was a moment when the disaster was still preventable. Not a dramatic moment marked by alarms or visible danger, but a quiet window of time when stopping operations could have reset the system. In complex industrial failures, this point of no return rarely announces itself. It passes unnoticed, disguised as routine progress. By then, the shipyard was already operating under false assumptions layered on top of one another. Structural loads had shifted incrementally. Temporary supports were bearing more weight than they were designed to handle. Mechanical tolerances were being stretched, not enough to trigger automatic shutdowns, but enough to reduce safety margins to almost nothing. Every minute that passed made correction more difficult, more expensive, and more politically risky. Several individuals sensed that something was wrong. A senior engineer noticed an unusual stress reading and assumed it was a temporary fluctuation. A crane operator felt resistance that did not match expectations but trusted that calculations had been verified elsewhere. A supervisor hesitated before approving the next step, then approved it anyway, believing that stopping would cause unnecessary disruption. Each of these moments was a chance to intervene. None of them felt decisive enough to justify halting the operation. This is where fear becomes a silent driver. Fear of delaying schedules, fear of challenging authority, fear of being blamed for overreacting. In industrial environments where momentum is valued, stopping work can feel more dangerous than continuing, even when warning signs appear. The system rewards continuity, not interruption. That mindset pushes people forward when they should be pulling back. As the operation continued, the complexity of reversing course increased exponentially. Once massive components are partially moved, partially welded, or partially secured, stopping introduces new hazards. Undoing work can be riskier than completing it. The shipyard crossed into a state where intervention required not just a decision, but courage, coordination, and acceptance of immediate loss to avoid far greater damage later. At this stage, communication breakdowns were no longer isolated. They had fused into a systemic failure. Information about mounting risks was fragmented, delayed, or softened as it moved through the hierarchy. No one saw a single clear reason to stop everything. Instead, there were dozens of small reasons to keep going. Together, they formed an unstoppable force. When the final irreversible step was taken, it did not feel like a turning point. It felt like another routine action in a long sequence of routine actions, but structurally, mechanically, and operationally, the system had crossed a threshold. From that moment on, physics would take over. Human decision-making no longer mattered. The outcome was locked in. What followed was not a sudden surprise, but the release of all the accumulated errors, misunderstandings, and assumptions that had been quietly building beneath the surface. The shipyard was about to discover the true cost of ignoring the moment when stopping was still possible. Do you want me to develop Pico Leo? Sim, totalmente em inglês. Sempre especifica os tópicos antes de enviar os textos tópicos 6. The chain reaction begins. Once the point of no return was crossed, the system stopped behaving like a controlled industrial operation and started behaving like a trap slowly snapping shut. The first failure was subtle. A structural element shifted a few centimeters more than expected. On its own, it was not catastrophic, but that movement redistributed weight across adjacent supports that were never designed to carry it. Stress migrated silently, like pressure moving through cracks in concrete. Crane operators felt the change before they saw it. Loads responded differently, swinging with a delay that did not match their inputs. Motors compensated automatically, increasing torque to maintain position. That compensation masked the underlying problem while accelerating it. Hydraulic systems strained, bearings heated, steel groaned under forces that had not been accounted for in the original calculations. Inside the control rooms, data streams still looked acceptable. Readings hovered just below critical thresholds. No single parameter screamed failure. Each system was operating close to its limit, but not beyond it. This is how cascading failures survive oversight. They stay just inside the boundaries of what is considered normal, while the combined effect pushes the entire structure toward collapse. Then the second link in the chain, failed, a temporary support buckled, not dramatically, but enough to transfer load elsewhere. That transfer happened faster than humans could process. Within seconds, forces multiplied across interconnected components. What had been a localized issue became systemic. The shipyard's complexity now worked against it. The same interconnectivity that allowed efficiency also allowed failure to spread with terrifying speed. Teams reacted instinctively. Some tried to stabilize sections they could see. Others continued operations, unaware that conditions had changed. Communication lagged behind reality. By the time warnings were voiced, they were already outdated. The physical system was evolving faster than information could travel through human channels. Metal began to deform audibly. Sharp sounds echoed through the structure, pops, snaps, deep resonant cracks that experienced workers recognized instantly. Those sounds triggered fear, but also confusion. Was this expected? Had someone already accounted for it? Seconds mattered, and no one had a complete answer. As one system failed, it forced neighboring systems into emergency modes. Motors surged, supports shifted, and tolerances vanished. The shipyard was no longer responding to human intent. It was responding to physics alone. Every attempt to correct the situation introduced new stresses, new imbalances, new risks. At this stage, stopping was impossible. Even evacuation became dangerous as structures moved unpredictably. The chain reaction was fully underway, each failure accelerating the next. What had started as a misunderstood message had now transformed into an unstoppable mechanical sequence, racing toward a level of destruction no one had imagined possible. The moment the shipyard collapsed was not a single event, but a violent sequence unfolding in overlapping waves. What failed first did not look like total destruction. It looked like loss of control. Massive steel sections began to move independently, no longer responding to commands, no longer constrained by design. Structures that had relied on balance suddenly found themselves fighting gravity without support. A primary load-bearing element finally gave way. When it failed, the energy stored in the stressed steel had nowhere to go. It released instantly. Connected sections lurched, twisted, and slammed into adjacent structures. Cranes, still holding suspended loads, were pulled off alignment. Some snapped cables under extreme tension. Others tore their foundations loose, collapsing sideways in slow, horrifying arcs. Inside the dry dock, the partially assembled ship became a weapon against its own environment. Hull sections shifted unevenly, tearing welds apart as if they were paper. Steel plates buckled inward, then outward, creating shock waves that traveled through the dock floor. Workers who had seconds earlier been performing routine tasks suddenly found themselves running from moving walls of metal. The sound was overwhelming, a deep, continuous roar mixed with sharp detonations as components failed one after another. It was not an explosion, but it felt like an industrial avalanche of steel, concrete, and machinery. Visibility dropped instantly as dust, steam, and debris filled the air. Communication systems failed. Radios went silent or dissolved into static. Shouted warnings were swallowed by noise. Emergency protocols were useless at this scale. Evacuation routes were blocked by debris. Automated shutdowns, triggered too late to matter. The shipyard's safety systems had been designed for isolated failures, not for a cascading structural collapse driven by physics beyond human control. The environment became unpredictable. Floors tilted, platforms fell. Entire sections of infrastructure collapsed in seconds. Some workers survived by instinct, along-diving into recesses, climbing over debris, following sounds instead of signs. Others had no chance. The speed of the collapse outpaced human reaction. Time, areas that had been considered safe zones moments earlier became impact points without warning. When the motion finally slowed, the shipyard no longer resembled a place of construction. It looked like a battlefield. Twisted steel lay piled where carefully planned structures once stood. Cranes were broken silhouettes against the sky. The dock itself was fractured, flooded, and partially destroyed. The collapse had not just damaged a project, it had erased years of work in minutes. And yet, even in the aftermath, one truth became painfully clear. The destruction did not originate in metal fatigue or engineering miscalculation alone. It was the physical expression of an invisible failure that had occurred much earlier. The collapse was simply the final, visible chapter of a story that began with a single, misunderstood message. When the movement finally stopped, the scale of the loss became impossible to deny. What had once been one of the most advanced shipyards in the world was now a field of twisted steel, collapsed infrastructure, and shattered machinery. The immediate priority was survival. Emergency crews moved cautiously through unstable debris, listening for voices, scanning for movement, knowing that every step could trigger secondary collapses. The human cost was staggering. Workers were injured by falling structures, crushed by shifting components, or trapped beneath debris with no clear access routes. Many had been following routine procedures moments earlier, standing in areas previously designated as safe. The speed of the collapse meant that warning time was measured in seconds, not minutes. Some escaped by chance. Others were caught in places no safety model had ever considered high risk. Beyond the injuries and loss of life, the psychological impact was profound. Survivors described a sense of disbelief, replaying the moments before the collapse, trying to understand how an ordinary workday had transformed into catastrophe. For many, the shipyard was not just a workplace, but a symbol of stability, expertise, and national pride. Watching it fail so completely shattered that sense of trust. Material losses quickly reached historic levels. Entire cranes were destroyed. Dry dock infrastructure was rendered unusable. Partially completed ships projects representing years of labor and billions in investment were damaged beyond repair. Precision equipment was buried, flooded, or warped by structural distortion. Supply chains, linked to the shipyard, were disrupted overnight, affecting industries far beyond the waterfront. Insurance estimates struggled to keep pace with reality. Initial figures were revised upward repeatedly as the true extent of the damage emerged. It became clear that this was not just another industrial accident. It was the largest financial loss ever recorded at a shipyard, eclipsing previous disasters by a wide margin. The economic shock rippled outward, impacting contractors, suppliers, and entire communities dependent on the shipyard's operation. What made the losses even harder to accept was their preventability. Investigators would later note that no extreme weather, no external attack, and no unexpected material defect had caused the collapse. The systems had functioned as designed right, up until human assumptions and miscommunication pushed them beyond their limits. The destruction was not the result of one dramatic failure, but of many small decisions that aligned in the worst possible way. As the dust settled, attention turned to accountability. Families demanded answers. Workers demanded explanations. Industry leaders faced uncomfortable questions about safety culture, communication protocols, and the true cost of prioritizing efficiency over clarity. The shipyard's ruins stood as a physical reminder that in complex industrial environments, the greatest risks are often invisible until they become irreversible. In the weeks that followed the collapse, investigations began with urgency and caution. Multiple agencies, engineering boards, and independent experts were brought in to analyze what had gone wrong. At first, attention focused on physical evidence: fractured steel, failed supports, distorted foundations. Engineers mapped stress points, reconstructed load paths, and simulated the final moments before the collapse. But the deeper they went, the clearer one conclusion became. The structures had not failed randomly. They had failed exactly as physics dictated once human decisions pushed them past safe limits. Early reports avoided assigning blame. Language was careful, technical, and neutral. Phrases like procedural ambiguity and operational misalignment appeared repeatedly. Yet behind those words was a far more unsettling reality. There was no single mechanical defect to fix, no faulty component to replace. The disaster had emerged from normal operations carried out by competent people following what they believed were correct instructions. As testimony was collected, contradictions surfaced. Different teams described the same moment in entirely different ways. Some insisted operations had been paused. Others swore they had explicit authorization to proceed. Time-stamped communications did not align. Verbal instructions had overridden written procedures. Informal confirmations replaced formal approvals. Each shortcut seemed harmless in isolation. Together, they formed a system where accountability was diluted and clarity was optional. One of the most disturbing findings was how warnings were softened as they moved upward. Concerns expressed on the ground were reframed as minor deviations in reports. Uncertainty became within expected variance. By the time information reached decision-makers with authority to stop operations, it no longer carried the urgency it deserved. The system did not hide the truth deliberately. It filtered it into irrelevance. Investigators also uncovered cultural pressures that discouraged interruption. Workers described an environment where stopping work required justification, but continuing did not. Schedules, budgets, and reputations created incentives to interpret ambiguous information in the most convenient way. Asking for clarification slowed progress. Proceeding maintained momentum. Over time, that imbalance shaped behavior at every level. Perhaps the most uncomfortable truth was that existing safety systems had not failed. They had been bypassed by assumptions. Protocols depended on clear communication, but communication was treated as a background process rather than a critical control. The investigation concluded that if a single message had been explicitly confirmed, documented, and shared across teams, the disaster likely would not have occurred. When the final report was released, it shocked the industry not because of what it revealed, but because of how familiar it felt. Many organizations recognized the same patterns. In their own operations, the shipyard had not been uniquely reckless, it had been dangerously normal. And that realization raised a question no investigation could fully answer. How many other disasters were quietly forming, waiting for a similar breakdown to expose them? Long after the wreckage was cleared and the shipyard fell quiet, the most enduring damage was not visible in steel or concrete. It lived in procedures rewritten too late, in meetings where executives promised change, and in an industry forced to confront a truth it had long avoided. The collapse did not happen because technology was inadequate. It happened because communication was treated as an assumption rather than a system that needed to be designed, tested, and enforced with the same rigor as any mechanical component. In the months that followed, new protocols were introduced. Mandatory written confirmations replaced verbal approvals. Cross-team briefings became more formal. Redundant checks were added to critical operations. On paper, the industry evolved. But beneath those changes, a quieter legacy remained. The realization that modern industrial disasters are rarely caused by a single dramatic failure. They are born from small gaps that grow unnoticed inside complex organizations. What made this loss historic was not only its scale, but its simplicity. No storm, no sabotage, no unprecedented technical flaw, just people speaking, listening, and understanding differently while assuming alignment. That realization unsettled shipbuilders, engineers, and safety experts worldwide, because it meant that the same conditions existed almost everywhere. Anywhere complexity outpaces clarity, the risk quietly returns. Some lessons were absorbed. Others faded as memory softened and pressure to deliver resumed. New generations entered the workforce without living through the collapse firsthand. Over time, urgency gave way to routine again. The danger of communication failure never truly disappears. It waits patiently, hidden behind efficiency, confidence, and familiarity. Today, this disaster is cited in training manuals and safety briefings, often reduced to bullet points and diagrams. But stripped of its human context, the lesson loses power. The real warning is not about cranes or hulls or supports. It is about how icily intelligent, experienced people can drift apart in understanding while believing they are perfectly aligned. The shipyard was rebuilt. The industry moved forward, but the legacy of that single misunderstood message remains a quiet reminder that the most destructive failures do not announce themselves. They whisper, they blend into routine, and they rely on the assumption that someone else has already made things clear. If you made it all the way to the end of this story, it means you understand something most people overlook. Disasters like this do not begin with explosions or collapsing steel. They begin with silence, assumptions, and messages that were never truly understood. If this story made you think differently about safety, communication, and responsibility, subscribe to the channel now. These are the kinds of industrial failures that are rarely explained in full, and new stories like this are coming. Leave a like if you reach the end. It helps this story reach more people who need to hear it. And leave a comment below writing this exact phrase. Communication is never a detail. If you want to continue, the next video is already on your screen, diving into another real industrial disaster where a single overlooked decision changed everything.